So now it's on recording mode. We are starting polynomial functions of higher degree. As you already know, we have discussed polynomial functions of degree 1, that is linear, polynomial of degree 2, that was quadratic equations. And now we are discussing general polynomial degree, higher degree, polynomial functions of higher degree. Clear? So first of all, recall what is in fact polynomial degree, polynomial function. Sorry. So this was definition of polynomial functions of degree n. Where why? Because we are uh, discussing degree n, so that's why this leading coefficient a n cannot be equal to 0. Why? Because if this coefficient or leading coefficient will 0, then this will be again remain polynomial, but that will be degree of n minus 1. So for degree n, this should not equal to 0. And for polynomial, as you know that okay, this n, or in other words, power of these variables should be integers, positive integers including 0, or you may use natural numbers including 0. So this was polynomial degree, definition of polynomial equations of degree n. But the problem is, if you have given graph, how you can determine whether the graph will be polynomial functions or not. So there are some properties of polynomial functions. First property is polynomial. The graph of polynomial functions will always continuous. Okay, so whenever you had plot any polynomial graph, that will be always forever continuous, just like this one. But if you see here, uh, if there any gap, just like here in this B example, so this graph is disconnected here, 8 point, let's suppose A. So this cannot be graph of polynomial. So the first property of graph of polynomial is polynomial uh, will always generate a continuous graph. Okay, and the other property is there will be a smooth round trend in polynomial. Okay, so there is smooth round trend, means opposite of this smooth trend is sharp. For example, this trend, this corner point cannot be the graph of polynomial function. So whenever we have a turning point in polynomial, it will looks like a very smooth, just like this one. Clear? So if there is any sharp, just like V, or corner, clear, or just like so. This cannot be graph of polynomial. So the second property of polynomial function is this graph will always contain a smooth corner, not a sudden chop. Okay. So in these properties, you can easily determine whether the graph of function is polynomial or not. Clear? Okay. The third property is okay. These are two property. Further, we have to examine more the graph of function. So we have a power function. For example, if we remove all terms and if we talk only this function f of x equal to x over n, this is known as power function. Okay. So for this function, for n we have two possibilities, whether n is even or n is odd. So you have to determine the behavior of both types of function. What will be graph if n is even and what will be happen if n is odd. So let us assume you may compare the graph of quadratic function for even, clear, or graph of uh, x power 4. Okay, here in quadratic equation, as you know that okay, the graph will be parabola either upward or downward. Okay, but when you have compare with odd function, for example, odd power, sorry, x power odd, for example, x power 3, y equal x power 3, or y equal x power 4. So you will come to know that we have positive value in range as well as negative value in range. But here you will get always positive for n equal to even. Clear? So if n is your even, this will always give you positive. If our leading coefficient is positive, what if I write f of x equal to negative x square? So this will give you always parabola downward, and the value of y or value of range will be always negative. So here you can uh, easily compare, and you can come to know that okay, whenever we have even power of power function, then we will get either completely a graph above the x-axis or completely below the x-axis. This is property of even power. And what about odd? For odd, we may get both, sometime positive and sometime negative. And other thing you may also notice increasing or decreasing function. Okay. So again, we have same kind of examples. You may read on your own basis, but the main point is I want to show you the some properties of these power functions. So before properties, we have a leading coefficient test that you already know in quadratic function, but now in this time we are generalized. We have generalized property of any leading coefficient function, leading coefficient test. Okay, so this test is known as the leading coefficient test. Uh, First of all, you must know what is leading coefficient. As I told you in the definition, the leading coefficient is in fact a coefficient, a real number that is multiplied with term having highest power. So why? Because this n is greater than all other powers. So that's why now the coefficient of this highest power xn will be known as the leading coefficient. So here in this equation, an is leading coefficient. Is it clear? So if an is leading coefficient, then according to leading coefficient, you may easily understand the behavior of graph. Along with leading coefficients, you have to see what is in fact n, whether n is odd or even. So we have in fact four possibilities. If n is odd and leading coefficient, it's let's suppose positive, or leading coefficient is negative. Clear? And if n is even, n is even, again for n is even, we have two possibilities for leading coefficient. Coefficient an, let's suppose positive, and an negative. So in fact we have four possibilities, and as you know that this leading coefficient cannot equal 0. Why? Because we are talking polynomial of degree n. So if this cannot equal 0, then we have either positive or negative for even, and positive negative for odd only. So what will be the behavior? Behavior means here we are talking generally, not exact graph. So ultimately, where or how the graph will be looks like, and where it will be go whenever we put largest or smallest value of x, that is tending, means mathematically we have to write, if x tends to 0, means if we put a largest value of x, where will be graph of function, that will be known as the behavior of the function. So means if you are not getting in general, you have to keep particular uh, cases in your mind, then you will easily come to know. So I am plotting here uh, particular cases. Let's suppose for easy understanding, I am giving you example of again same quadratic and cubic for even, and quadratic for odd. So what will happen if I am writing, let's suppose for first case, let's suppose n is even, and an positive, and an let's suppose negative. So take example of quadratic function, as you know already. So for this example, I may write x square simply here. So here you may see that graph of this function will be parabola. So now what will be happen if I put largest value? If I tends x tends infinity, where function will go? Function will also increase, as you know that this is increasing. Okay, so this will be increasing. And in the same way, what will happen if I put x very small is, x tends to negative infinity, for example. Clear? X tends negative infinity, but again you may see here the value of function is also greater and greater, just like here. So again in both cases, either x tends positive infinity or negative infinity, function will always go to positive. Is it clear for this example only quadratic equation? Clear? Then we will generalize, and in the same way, if our leading coefficient is negative, so take example of again same f of x equal to negative x square, and here you can see that the graph of negative x square will be parabola downward. But graphically you can easily understand whenever we put largest value of x here in this portion, you will see the value of f of x will be negative. Clear? So this thing mathematically I may write f of x tends negative infinity. Again in the same way, if I put left side for example here, so if x tends negative infinity here, again the function y, because graph is below this x-axis, so the value of function will be negative, and negative largest value will be known as negative infinity. So in both cases, whether x is positive infinity or negative infinity, f of x will tends to negative infinity. Is it clear up to here? Means if we have even power, and if they depend on leading coefficient, if leading coefficient is positive, then function will tends to positive infinity. If our leading coefficient is negative, then function will be negative infinity for even. Now I'm giving you example for n is, let's suppose, odd. So again we have two possibilities for leading coefficient. A n is, let's suppose, positive. For this kind of this kind of case, you may again use a simple example. For example, f of x equal to x cube. Okay, or you may use also linear equation f of x equal to x. That will be again so simple for you. So this is why, because straight line. So for straight line, as you know that slope is positive, so this graph will look like this one straight line. For in cubic, as you know that okay, this will look like okay. So there will be smooth trend here on at origin, but imagine it's smooth trend. So this will be in fact graph of x cube and x. So leading coefficient is positive, n is odd. So how you can generalize means, if I put in both cases a very large number, if x tends to infinity, where your function will go, function of these two examples will go. Here you can see that the function is increasing. Here you can also see that the function is increasing. So both cases, when x is very large, function will also give the largest value here. But when I put x very small is, x tends to negative infinity, for example, here you can see that function, the value of f of x is decreasing and it is negative. You may sorry, a function graph of function is below this line, so this negative, and graph of this here, you may easily note there is a same pattern. If x is negative infinity, then function will also give you the negative infinity. So this is third case when n is odd and leading coefficient is positive. So in the same way, now fourth one is again, if n belong to odd, but our leading coefficient this time is negative. What will happen now? Again, before generalize, that will be easy if you take a simple case to understand and to remember also. Clear? So again, I'm taking same example, linear and quadratic. Let's suppose f of x, leading linear and cubic. Let's suppose f of x equal to minus x cube. You may use g of x equal to negative x. So in both cases, here you can see why, because our slope is negative. So the graph straight line will be sorry, will be from second to fourth quadrant. Okay, and here you may also know this is very basic uh, function already you learned from chapter 1. So the graph of this function will be, there will be smooth corner just like this one. I mean, assume this is a graph of negative x cube. So while looking graph, can you tell me what will be behavior of these two functions? Behavior means, if I go through the right side of x, where our function will go, and if I again go the left side of this domain, where will my function, where will be function, sorry, where will be function will go. So here you can see that x is positive, but the value of function will be negative infinity. In the same way, you may easily notice that. So now, while looking these four examples, now I'm talking generalized version of these four. Okay, let me now recall these definitions. So this is in fact summary of our discussion, leading coefficient test. So eventually, where function will go means whether it will be rise or fall. Uh, so we have four possibilities. Again, so far even n is odd. For first of all, take example of n is odd. So if n is odd, and you have to see what is leading coefficient. So if leading coefficient is positive, clear? If leading coefficient is positive, function go increase or go to the positive infinity as x increases. Clear? So for here in this part, first example, there is, you may use also direct relation. If x increasing, function is also giving you the highest value. Clear? And if x goes to negative infinity, function will also give you the same negative infinity. There is a direct relation. In the same way here, if our leading coefficient is negative, okay, and n is odd, we have reverse relation. If x tends to positive infinity, function will go to the negative infinity, and if x go to negative infinity, function will go to the positive. So that is same that we already discussed in particular example. And again, for n is even, and if leading coefficient is positive, then the graph rises to the left and to the right. So if x is uh, either go to negative infinity, either go to the positive infinity, function will always rises both sides. Clear? And if our leading coefficient is negative, x tends infinity or x tends negative infinity, function will always fall. Means that will be go to the negative infinity both sides. Okay, so why? Because these are general cases. So we have dashed portion here. So that will be depend on remaining terms. Means now we are talking only the leading coefficient. So these arrow are telling only the leading coefficient. Due to leading coefficient behavior, we can eventually see the behavior of the graph at the long way. But at the smallest value, at the middle value, we don't know where it will be. It maybe looks like means in general, if I talking for this case, so function will be looks like here, but we don't know what will be its let's suppose middle gap of the function. That will be totally depend on other remaining terms that we are not discussing right now. So that's why we have dashed here in this graph. Clear? So if parabola is negative, then it will be looks like this one, but we are talking now generally even function. So they cannot be quadratic. They may be power 4 or power 6 or power 8. So, but these leading coefficient is only telling you the long-term behavior. X tends to positive or negative infinity means the graph eventually go down at the both sides, but in middle we don't know how it will looks like. Okay, so this is regarding your leading coefficient test. I hope you got the idea. And uh, while applying the leading coefficient now, you may easily understand the behavior of these graphs. For example, here you may see that f of x equal negative x cube plus 4x, and the question is describe the left hand and right hand behavior. Left and right hand behavior means if x tends to positive infinity, this is right hand behavior. Right hand behavior, clear? So you have to tell where function. So if you fill the blank of this function, that will be answer of the right hand behavior. In the same way, if x tends to negative infinity, this is known as a right hand behavior. So in order to answer this question, you have to just tell what will become, what should we write here. Okay, so this question is asking. So you have to in fact apply the leading coefficient test, and while applying leading coefficient test, you will easily come to know the answer of this question. Clear? So why? Because this is example, and you can read, and you can also particular you can plot the graph of particular functions here. Now, why? Because these are basic functions. Okay, so the next topic in this exercise is real zeros of the polynomial function, and that is, I think, we have already discussed in previous chapter. But once again, why? Because this is very important. Once again, you have to recall definition of real zeros. Okay? Why? Because in order to solving the equations or solving the system of equations, we need zeros. So in general, zeros is solution of any function. For example, if f of x equal to 0, what will be x here? these x value of x will be zeros. But if our function is polynomial, then we are known as zeros of the polynomial functions. And for zeros of the polynomial functions, we may have two options. Zero may be real, may be complex, but here, as I told you, that our domain is only real to real, so we will discuss only real zeros of the polynomial function here. So there are complex zeros of the polynomial function, but we are not interested in complex zeros of the So I'm repeating the definition of real zeros of the polynomial functions. Okay, if f is your polynomial function and a is real number, then statement listed below are equivalents. These four statements are same, are equivalent with each other. So if I am saying that x equal to a is zero of the function, it means whenever I will put instead of x a, the function will give you zero. Clear? So that's why the second point is telling you same thing. If x equal a is the solution of the polynomial equation, means f of x equal to zero. Clear? And if f of x equal to zero, then what will be its factors? Means if I divide a polynomial by x minus a, that will be complete divide. So x minus a is the factor of the polynomial of the f of x. We will discuss uh, this thing, the factor, in detail with factor theorem. But whenever we have f of x equal to 0, then x minus a will completely divide. You will get a remainder 0. Clear? And the second thing is what will be this thing graphically. So function will intersect here. So this a comma 0 will be known as x-intercept of the graph. So these four are equivalent statements with each other, and that is related with real zeros of the function. So graphically here you can see that okay, we have three zeros, x equal to 1, x equal to 0, or x equal to negative. Okay, here these functions are giving you the zero value of function will be zero while putting these three x intercept. Okay, these are very special in turning points also. Why? Because as I told you that we have zero in between positive and negative value of the function. So this zero is get in between positive and negative. So here you can see that okay, function is negative here. Here function is zero, but here again function is positive. Clear? But then here function is uh, zero and function is positive. This is in fact turning point, but uh, the value of the function is same, both positive versus positive. Okay, but here you can see that we have a positive, zero, and negative. Clear? So how you can now generalize these things and how many turning points are there? You may see that this is a turning point, clear, where function is changes its behavior from increasing to decreasing. So there is a difference between positive and increasing, negative and decreasing. Clear? So you may not confuse with these two terms. So turning point is a point or a situation where function changes the increasing or decreasing. Clear? So increasing and decreasing, you may consider the slope of the graph, but positive negative means the value of the function, outcome of the function means whether the graph is above this horizontal line x-axis or below this line x-axis. Clear? Okay. So now this is a particular example, but we are now generalizing this thing. What will happen? Okay, so take example of that equation, this function. If in order to finding the zeros, we have to solve this kind of equation f of x equal to 0. So f of x is negative 2x power 4 plus 2x square equal to 0. Clear? And if we take negative 2x common, so we have in fact 4 real zeros, means 2 are repeating 0 0 and negative and 1. So here you can comparing how you can generalize this thing. So I am telling you, so the real zeros x equal to 0, x equal to 1, x equal to negative 1, and corresponding x intercept are 0 0 1 0 and negative 1 0. The function is fourth degree polynomial. Here the degree is 4, means highest power of variable is 4. So the graph f can have at most 4 minus 1, 3 turning points. So in general, if we have n degree polynomial, so we will get at most n minus 1 turning point. And this thing you may notice from parabola, as you know that the parabola is equation of polynomial degree 2, but we have one turning point. So 2 minus 1, one turning point. Clear? So this is at most. Clear? What do you mean by at most? Means this function will not have greater than 3 turning point. It may be lesser than. So means this is the most maximum you may use, maximum turning point of 3, but it may be 2 or it may be 3 or it may be 1 turning point, but the graph will always have in general at most. Okay, means in mathematically we will use less than or equal to n minus 1 turning point. Here you can see that we have 1 2 3 turning point. Okay, okay, in example 3 you may also notice that the factor 2x power is minus 2x square yields a repeated 0, x equal to 0, means x equal to 0, x equal to 0. So this is known as the repeating rule. Why? Because we have square on x. Okay, so the exponent is even, and you may use you may see that the power is even. Okay, so the graph touches only x-axis only 0. Just like parabola. Okay, x square only touches 0, or minus x square will again touch at x equal to 0. So now I am telling you the generalized rule for repeated 0. So you have to think, or you have to see two things. One is the factor, and the factor is Saladin, camera band karo. So the factor x minus a power k, if k is greater than 1, yields a repeated 0. Clear? And x equal to 0 of multiplicity of k. So you will see how many k according to k we have to x equal to a multiply. Means if this is x power 3 equal to 0, so x will be 0 0 0 3 times. This will be known as the multiplicity of. Okay, so now these 2 points are very important. If k is odd, okay, means power is odd 1 3 5, just like 7. So for odd, as you know that okay, the graph is also give you positive or negative infinity. So that's why it crosses at x equal to a. It means it will be just like this is counter example. This not is crossing. This is just touching. But if our k is odd, then the graph will be passes through x equal to a. Okay. So this point is telling if k is odd, the graph crosses at x equal to a, and if k is even, then graph it touches at x equal to 0. So for second point, This is example of second point. So if k is odd, so graph will be not cross, but now it will go down, only touch. And in lowercase or in uppercase, it will, let's suppose, here is our a. So it will touches if k is positive, and if k is negative, then it in both cases these are known as x-intercept. But at x-intercept, sometimes graph will pass through if k is your odd, and if k is sorry, k is even, not zero. If k is even, then it will touch the x-axis. But if k is odd, then the graph will pass through the x-axis. I think you are getting my ideas. Yeah, this is pretty simple. It's straightforward. Okay. And if you feel any confusion, you may ask without hesitation. So while keeping these all points in your mind, now our ultimate purpose is to sketching any graph of any polynomial graph. Okay, not complete sketch, but somehow roughly we may also plot the behavior of the graph. But if graph is pretty simple, just like these kinds of graph, then you may sketch easily. Clear? Okay, before sketch, you may use your leading coefficient test, roots or multiplicity rules, each and everything. So in order to sketch, you have to follow this step. Now, first step is apply the leading coefficient test. This leading coefficient test will give you the overall behavior or long-term behavior of the graph. Clear? So why? Because leading coefficient is 3 and n is even, so it will go upward in both cases, just like this. Okay, so now from leading coefficient we come to know that, okay, the graph will never go at long term downward. Clear? And the second step is you have to see where graph will touches x axis. You have to find out x intercept. For x intercept, you have to determine real zeros of the function. Okay, for real zero of the function, you have to solve f of x equal to 0. So if we solve f of x equal to 0, then again here you can say that we have 3 multiplicity at x equal to 0. Okay, so and you may see that k, why? Because our k is odd, so function will go through from 0. Okay, and x intercept are 0 0 4 or 3. So while, okay, after these 3 steps, now the fourth step is sorry, number third step is very important. You have some additional point. This is very important. So after getting x intercept, you had plot a few additional points that is totally up to you, but the point should be in between these x intercept. Means point should be in between 0 comma 0 and 4 or 3 comma 0. Clear? So for example, I have written here, let's suppose an example, it is given 0 comma 4 or 3. And so if you plot these two x intercept on this real line 0 and 4 or 3, you may see that we have divided whole real line in 3 interval. This is 1 interval, 2 interval, 3 interval. So you had to plot, you had to determine some points in these intervals. So this interval mathematically we have to write from negative to infinity to 0. Why? Because at 0 we know 0, so this will be open interval. Okay, so you have to see some points in this interval. That will be totally up. You may use -1, -2, or -10, or -100. And why? Because graph will change behavior in these x intercept, but here in whole interval the behavior will be same. Clear? In the same way, here we have infinite points. Again, you had to plot some points in between 0 and 4 or 3. So mathematically we have to write 0 or 4 or 3. Clear? In the same way, x beyond 4 or 3. So in this interval, this example determining value of -1. So at -1, this is 7. that is positive, and in this interval we are putting 1, for example, and 1 it is negative. Clear? And at the last interval we are putting, let's suppose, 3 or 2. So these are totally up to you. If you are interested in -2, you may use -2, -3, but point should be in this interval. Clear? Here again we have, why? Because the infinite real number. So if you don't know 1, you may use any number beside 1, but the point should be in between 0 and 4 or 3. You may use, let's suppose, 0.1 or 0.001, any. There are lots of infinite. Again, in this interval you must at least 1 point. If you are interested more than 1, that is totally up to you. So but at least 1 point will give you the idea where will the graph of function go. Okay, is it clear? So now, keeping these all things in your mind, the in fourth step you have to draw the graph, draw the continuous graph. So before completing drawing graph, you may use these 3 steps: 1, 2, 3. So as you know that in first steps, we know that the graph will rises to the left and right. Why? Because n was even and leading option was positive. So these two things we got from step 1. Yeah, leading option. And the second step was, I think, we have plotted x-intercept. Clear? And the third thing is, as you know that, okay, yeah, we also plotted some additional point. Let's suppose in this interval 1 comma -1 comma 7, for example, -1 comma 7, and here in this interval it was, I think, 1 comma something. Okay, here there was a third step. I don't know, you see, but the main thing is, now after plotting these points, you also know that this is only x-intercept, and this is also x-intercept, but this is repeating x-intercept, and k was odd. So the function, the graph of function will will pass through, not touches. Means this will be go downward. Clear? And again, this is x-intercept, so function will change behavior just like. So we don't know exactly where will looks like, but roughly you may. And if you are getting more accurate, then you have to increase a number of points here in step 3. Okay, so if you are uh, plotting so many points here, let's suppose 10 to 5 here, 10 to 5 here, 10 to 5 here, and you are plotting on graph paper, that will be exactly the graph. So the figure, so the procedure is, the method is, you have to follow, uh, uh, after following these 4 steps, you have to construct graph in 2 steps. One is roughly sketch in the, just like in these arrows. Clear? And the second step, you have to join with smooth points. Means after plotting the extra points here, you have to finalize the graph. Okay, so that will be give you the sketch, or roughly the idea of graph of polynomial. So whenever you sketch the graph of polynomial, you have to anyhow follow these 4 steps. You must need uh, and you must follow the leading coefficient test, x-intercept, and all some points in between your x-intercept. Clear? So there is another example, you may see it. Okay, and why? Because this is example and already it is solved. So after completing the class, you may read you on your own basis. Okay, and you will come to know that this is same as we already discussed. Clear? Okay, so we have now an important theorem that is related intermediate value theorem. This is very important in calculus. You will learn in detail in calculus 1 as well as in pre-calculus. So this is very basic theorem of calculus that is known as intermediate theorem. Okay. So I am reading first of all, then I am explaining it how it works. Okay. So for intermediate theorem implies if we have 2 points, A f of A, B f of B, and there is assumption that the 2 points of polynomial function, and there is another assumption that both points both values are different, means f of A is not equal to f of A, and the graph is continuous. Okay, why? Because it is polynomial, so that's why the graph of polynomial will always continuous. Clear? So if our function is continuous in this open interval, clear, and with f of A is not equal to f of B, then this theorem is telling you there will always you may find a D in between f of A and f of B, and assume f of A here is lesser than f of B, for example. Okay, so or it may be reverse, so we are leaving this. So there is a D in between f of A and f of B, such that f of C will always equal to D. F of C is all, and C, where will be C? C will be in between your domain A. So graphically, you can see that if from A to B, it's continuous. So it
आवाज सही नहीं आ रही है, समझ ही नहीं।
f of C equal to. Okay, I'm repeating this thing that I already told you. Though I'm repeating this intermediate value theorem. So now listen me carefully. Let A and B are
सफाना तो समझ में जैसा ही।
okay. Let me complete once again. Let me repeat. So intermediate value theorem is telling you. So we have first of all two assumptions for theorem, and then we have some statement what theorem is telling. So I'm repeating. Let A and B are two real numbers. Clear? Is this thing is clear to you? And such that A is less than B, means we have interval, for example open interval, or you may use also closed interval. Clear? If f is a polynomial, means the graph of function will be continuous, such that f of A equal to is not equal to f of B. This is our main assumption. Okay, their initial and ending value of function will different. Then there is an interval, and from closed interval, f takes on every value between f of A and f of B. So graphically, if I explain this thing is, as you know that, okay, let's suppose A is our here and B is our here. Clear? So now from A to B means if I write here vertical lines. Okay, so here we have interval. So can you determine any continuous graph from this vertical line to this vertical line such that their endpoints will not equal? Means the function should not just like this one. Why? Because now here f of A will equal to f of B, but we are assuming that their initial and ending value are different. So we have two kind of possibility. Either function will be just like here, this one, and function will be just like here in this one. Okay, our function will be, for example, there are smooth curve just like here. So clear? So we have infinite possibilities while following these assumptions. Clear? So function maybe looks like here. Just initially and ending points should different. Clear? And function will be always continuous. So if these things will happen now, function is telling, this theorem is telling, sorry, this theorem is telling you that you will always find a value in between f of a and f of b in this in between a and b means uh, okay, okay, I'm writing here. Yes. So this theorem is telling you means if f of a is not equal to f of b, clear, and is continuous on this interval a to b, clear. So this function is telling you that there is a point c c in between a and b. For example, I'm giving a name c a and b, clear. So function f of c will always remain in between f of a and f of b. So this is obvious and integer, as you know that why, because function is continuous, and continuous function you will always find at least one point in between f of a, in between a and b, so that this function will give you f of c that will be always in between f of a. So graphically, as I told you that, okay, let's suppose this is a, this is b, clear, and function is continuous from this vertical line to this vertical line, clear. So here we have infinite c, means if you take any c, function will always, this f of c will always f of a and f of b. Okay, so imagine you may use you may construct any function that follow these assumptions. You will determine always, means what function will give you function, sorry, what theorem will give you. Theorem is telling you that there will be always c in between a and b, such that f of c is always in between f of a. If function is continuous and f of a is not equal to, is it clear now? Why this is very important? Why? Because as you already told you, uh, as I already told you that, okay, we have, for example, graph, a special graph that will, let's suppose I am giving you, for example, example of uh, continuous graph. Let's suppose here is our a, here is our b, clear, and the graph is, let's suppose, continuous, that is looks like b. So here you can see that, okay, f of a is negative and f of b is positive, clear, and a is less than b, and if so f of a is not equal to f of b. Now this theorem, this intermediate value theorem, will give you a guarantee. Why? Because a function is continuous and at end point it's negative and one other point is positive. So why? Because in positive and negative there is a zero, clear. So f of c will always will be zero, and this f of c will always in between f of a and f of b. So why? Because as you know that zero is in between positive and negative. So if function is continuous, and this must be intersect with zero. Okay. So this is related the intermediate value theorem. So you already know this before theorem, but now theorem is giving you the more authentication, and you may use now it without hesitation. Okay, if we have a positive value of function, negative value of function, then why? Because it's continuous, so there must be at least one zero, one x intercept. So how you can use this, and what this theorem is in fact giving you, that is very important thing. So you may get the idea clear from this example 6. For example, this example is asking use intermediate value theorem to approximate the real zeros of f of x equal to x minus 1. So why? Because we don't know what is with its real 0, and we are not solving analytically. So but we can put randomly some point. Means if I put -2, function will give you the negative value, and if I put, let's suppose, -1, it is again giving me negative value, and if I put 0, this function is giving you positive. So here we are interested in this interval, okay, from -1 to 0. So why? Because the value of function is changes -1 to 1. So in between negative and 1, there must be a 0. So one real root may be in between, and this interval in between -1 to 0. Clear? So how you can determine? You have to shrink your interval. Let's suppose if I put the midpoint of -1, 0 means -1 plus 0 upon 2, it will become -0.5. So I have to see what will become f of -0.5. Clear? So or you may use any other value in between this interval, in between this interval. So let's suppose why, because this is the example and it's explaining in better way, you may get the idea. So this intermediate value theorem is telling you that why, because f of -1 is negative, f of 0 is positive. So intermediate value theorem tells you that has a real 0 in between -1 to 0. Okay. uh, the pinpoint this 0 more closely, divided by interval into tenth, or evaluate function at each point. For example, if we are converting this interval into 10 sub intervals here, so if I divide, let's suppose, -1 plus 0 divided by 10, so we have -0.1 of interval. So we are taking at these intervals, means what will be f of -0.1, what will be -0.2, -0.3. So eventually you come to know that f of -0.8 again negative. We are only interested in sign, whether it is positive or negative. We don't exactly uh, need a particular value, but you have to see it's is it positive or negative. And at -7 and -0.7, sorry, the function is positive. So here you can assume, or you can see, our intermediate value theorem will again guarantee you that function will contain a 0, or function have a 0 uh, in between these intervals. So there is, again, we have now -0.7 to, so -0.8 to -0.7. So function will get a 0 in these two intervals. Why? Because f of -0.8 is negative, f of -0.7 is positive. So if you are not taking analytically, then you may get approximate, and that point will be, let's suppose, in between these two numbers, means in between means -0.8 plus -0.7 divided by 2. uh, you may also write that we don't know exact, but approximate. This is numerical method. In fact, approximate x is equivalent to midpoint of these -0.755 is 0, means this thing is f of -0.755 will give you the 0. This is, or this will be x-intercept. Okay, this is related to the intermediate value theorem. So this is all about your exercise 2.2, and this 2.2 is very important. Why? Because here in this exercise we have covered a lot of very important topics. Zero of the function, and graph of the polynomial function, and intermediate value theorem. So these all steps are very important. You have to read it rigorously, and you have to solve exercise, solve question from exercise rigorously, so that you can get each and every concept clear. I hope you all are with me.
Yes, sir.
Yes. Okay, we have last exercise for this chapter, and then we will move to the chapter 3. So before we starting chapter 3, you have to recall polynomials that we already discussed, and there is a division that is known as synthetic division that we already learned in I think first year in third class here. So once again, we are, if you also don't know, don't worry, we are repeating these two things once again. Okay, for division, synthetic division, you must know how you can divide two polynomials. That is known as long division polynomial. Okay, so in division we have two to three terminologies. You must know what is divisor and what is dividend and what is in fact remainder. Okay, so in general, I am telling uh, if I divide polynomial means if I divide x cube plus 3x plus 5 so x plus 1, then this x plus 1 is known as divisor, okay, or and this term is this polynomial is known as but after getting the result, let's suppose this is y because example. So this answer is known as the quotient, and this is this is same thing happening as you already divided numbers. Means, for example, if I divide any number 5 with 3, clear? So how can I write? I have to write 5 is my y plus dividend, and this 3 is divisor, clear? And so I have to use table of 3 at 5. So 3 1 the 3, 3 2 the 6, 6 is greater than 5. So I have to apply only one time. So 3 1 the 3. And then I have to subtract when 5 minus 3 will become 2. So if I am not go to the decimal places, then because this 2 is lesser than 3, then this 2 is my remainder. Here, this is remainder. This is your quotient. This is divisor. You know very well these things from school level. So these are same. But you may also you may also know the relation very well. Is it clear? My कोई मसला तो नहीं? Okay, you already know that there is a relation in between quotient, dividend, divisor, and remainder. So here in this example, if you divide 5 to the 3, then this 5 can also be written as 3 1 the 3 plus 2. So what is 5 here? What is 3? What is 1? What is 2? In general, we have a relation that I am going to write. So this 5y plus 5 was dividend. This will always will equal to this 3 or this 1. 1. What is 1 here? 1 was your quotient. And what was this 3? 3 was your divisor into quotient plus remainder. Clear? So this is very special relation that you may check with any numbers. Clear? So whenever you divide any two real numbers, you will get this relation called. Clear? So now we are generalizing this relation with polynomial functions also. But before generalizing relation, you must know how you can divide. Okay, that is known as a long division. I hope you all are very well from this method, but even then I am repeating. Okay, so first of all, for example, there is example, we are dividing 6x cubed minus 19x square plus 16x minus 4 by x minus 2. Clear? So our question is, let's suppose 6x cubed minus 19x square plus 16x minus 4 is divided by, let's suppose, x minus 2. So how you can divide? You have to get idea from this example. Clear? I know most of you know very well, but even then, if anybody from you don't know, then you have to uh, see clearly or conceptually how you can divide two polynomials. So first of all, as I told you that whenever we are dividing two numbers, we have to write dividend within the bracket and divisor out of the and in numbers we were applying the tables, but here you have to see the first terms of divisor and first term of dividend. These are very special. Now just you have to divide both first terms. So what will happen if I divide 6x cubed minus 6x cubed by x? So 6x cubed by x will give you 6x square. So now you have to write this 6x square in the quotient. You have to write this as a quotient. And now whatever there is a quotient, you have to multiply with whole your divisor. You have to multiply with x, you have to multiply with 2. Okay, so this will become 6x square times x, 6x cube, and 6x square minus 2 will become minus 12x square. And then as you already do with numbers, you are subtracting this. So while subtracting, this positive and negative will be cancel with each other, and negative will become positive. So minus 19x square plus 12x square will become 17, sorry, negative 7x square. Clear? And you have to bring the remaining terms down, plus 16x square minus 4. Or you, it is up to you. You may write whole terms, but you are periodically writing down. It's totally up to you. Okay. So you may also write here minus 4. Clear? So again, we are repeating now same process. This is just like iterative process. You have to see again your first term of the divisor and first term of your dividend. Clear? And you have to divide these two terms. So as you know that now negative 7x square, if I divide negative 7x square by x, this will give you negative 7x. So again, you have to write negative 7x as a quotient, same step, and then you have to multiply now this negative 7x with this divisor, both terms of the divisor. Clear? Okay, so negative 7x into x will become negative 7x square, and negative 7x into negative 2 will become positive 14x. And again, you have to subtract. This negative sign will be converted into positive, and this positive will be converted into negative. So this negative positive cancel, plus 16x and minus 4x, 14x will become 2x, and you have to bring the last term negative 4. So again, you have to apply this process now third time. So you have to see first term here and first term here. So 2x divided by x will become 2. Write down 2 in quotient form and multiply quotient with divisor. So this will become 2x minus 4. And after subtracting, you will get 0 and 0 here. So this is our remainder. Okay. So you may also get here any non-zero term or any expression, polynomial expression whose degree will always lesser than this expression. And why? Because and this is a linear, so less than the linear will be any constant number. But if your divisor is, let's suppose, quadratic or polynomial of degree 2, you may get remainder less than polynomial of degree 2. That will be, it can be linear, can be a constant number. Okay. So again, you can see this is the same relation that we discussed. A divisor is equal to divisor times quotient plus remainder divided by 0. So you add 0 or not. And here you can also see that why, because remainder is over 0, then these two are factors of this whole polynomial. Okay? So again, we will learn if remainder is 0, then the divisor will be known as a factor of this polynomial expressions. Clear? So is it clear up here? Okay, is it clear up here? Okay, his voice is clear. Should I use a headphone or it's okay for voice? Because now I read your messages and so many students are asking there is problem in my voice. But you have to once again see if it is needed of headphone or not. Okay, is it clear now? Okay, I'm generalizing the division algorithm that we discussed with the help of example. And if these are very simple and straightforward. If you read throughout your textbooks, you will understand easily if you find there is a voice problem. But I think there is no any difficult thing in this that we already discussed. But even then, if you feel any difficulty, you may ask separately. Okay, so these are very simple and straightforward. So now we are once again repeating our division algorithm. Okay, so this algorithm is known as division algorithm that we already discussed with help of numbers. Here, remember we discussed 5, 10, we recognized 3 times.
voice
1 plus 2. Clear? Okay, so in general we have dividend will always equal
वॉइस क्लियर नहीं आ रही
up.
सर बफर आ रहा है वॉइस में
सर बिल्कुल भी सही नहीं है
सर आवाज सही
सर आपका एयरफोन का इशू होगा मे बी माइक
आपके इस वॉइस में भी मसला है, तो हो सकता है आपका मसला हो। बाकी बताएं, बाकियों के पास आवाज सही आ रही है?
नहीं सर
नहीं
हमें
सर,
एक दूसरे से सही आ रही
आपको
है।
भी आवाज नहीं
हमें
है
एक दूसरे से सही आ रही है, आपकी तरह आ रही है।
आपकी वॉइस क्लियर नहीं है।
हेलो, इज इट ओके नाउ?
नहीं सर
What about now?
Still, sir.
सर अभी तक सही नहीं आ रही आवाज
सर आप रिपोर्ट करके भेज दें इनको।
सर ये डिस्कनेक्ट करके फिर से कनेक्ट करें
Okay, now what I have to do, I will take in whatever I'm telling you means key points and special are basic and important things I have to write down so that you will easily understand. If there is means
सर समझ नहीं आ रहा
problem
आवाज
in my voice,
सर आवाज
that's
समझ
why
नहीं
you
आ
will
रही।
focus on also and writing clear. So once again, I'm repeating the Debian algorithm in general as a whole. Okay. So how you can use and what is the purpose of this Debian algorithm? It is if you have divided
सर आवाज
integer
समझ नहीं आ रही।
quotient reminders, so there is a relation in general I had to write.
अबू एक 2 लाख का 7 लाख फोन लैपटॉप दो है ना हमें नंबर आओ ये चाहो तो खर्चे के नंबर अच्छा नहीं हां तभी दे दे क्वेश्चन मौजूद नहीं हमारे देखो क्वेश्चन हमें के मैं हां हमारे संग पे ऊपर है ना फायदा करो मिले हां हमारे 5 लोटा करने 5000 देते हैं हां ये तान के मैसेज थोड़ी है
Thank you so much. Hello. Okay, what about now?
नहीं सर, अभी तक आवाज सही नहीं आ रही है आपकी।
मैंने माइक चेक कर ली।
सर सर आवाज नहीं आ रही तो अगली क्लास में हम इसको कर लेंगे ना कहो सारा क्लियर।
नहीं, इसको खत्म करना है ना अभी हम।
सर ये अगली क्लास में कर लेंगे ना।
नहीं, इसको हम आज चैप्टर 2 भी करेंगे, 3 भी करेंगे और 4 और 5 करेंगे।
सर आज तो
सही आ रही है आपकी स्टॉप हो जाएगा।
सर यहाँ आवाज में बहुत मसला आ रहा है, आपकी आवाज
सर आप
बिल्कुल क्लियर नहीं आ
रिकॉर्ड
रही।
करके भेज दें, नहीं तो
चलिए हम इस तरह करते हैं, इस एक्सरसाइज को मैं खत्म करता हूँ, उसके बाद हम क्लास खत्म करते हैं और फिर हम जो नेक्स्ट चैप्टर है 3 वो हम नेक्स्ट क्लास में करेंगे।
सर समझ नहीं आ रहा, आप मतलब आवाज समझ नहीं आ रही।
हाँ, मैं बता रहा हूँ कि अभी हम इस क्लास को ना इस चैप्टर तक रखते हैं और उसके बाद हम नेक्स्ट क्लास में ना नेक्स्ट चैप्टर करेंगे। सही है, तो लेट मी कंप्लीट। So I was telling there is a relation between these four steps: dividend, quotient, divisor, and eliminate. I means give you the example numbers. So now we have to follow these things with polynomials also. Here, you may also get another relation if I divide, let's suppose d of x here. Okay? D of x will are 3 times, then you will get this algorithm. So this same are you are exposing this done this expression or this relation. Okay. So again, we have a second example of long division. This method is known as long division, and it we already learned from first example. Okay. But one thing that you have to notice, that is very important thing in long division methods. Okay. So long division method is very lengthy sometimes. It takes time, so that's why we are now comparing some. There is a pattern while dividing. Okay. So after seeing these 2 to 3 examples of long division, you come to know that there is a pattern in divisor and dividend. Okay. And that pattern is generalized in this division that is known as synthetic division. Okay. And now we will discuss that pattern in so we are not going in detail, but you come to know that there is a pattern, and that pattern is I'm telling how you can divide another method that is so simple and so easy and less time consuming by because here we are dealing with only coefficients. Okay. So while dividing any polynomial with scientific division, you have to write coefficients in ascending order, and if any missing term is there, you may write a 0 instead of base term. So as you already, this is a term coefficient of x cube, coefficient of x square, coefficient of x, and constant here, and u bar y because dividing x minus k. So for x minus k, you have to set this term 0 means divisor equal 0 means x minus k 0, then value of x will become k. Now in other words, in scientific division you would write here. Okay. And in first row you would write all coefficients are divided just like ABCD. Okay. And now what is pattern and what is method of this division? This follows that first of all you will keep this first term leading coefficient as it. Okay? So if there is A, then you will write A same as it. And then you will multiply A with K, that will become AK, yeah, AK. Okay? And then you will add these terms. So B plus KA will become B plus KA, and again you will follow this same pattern, multiply with K and add with second term. So in fact, we are getting this idea from example that will be easy for you. Okay? So let me see any example that will be give you the more insight in this pattern. Okay, so I'm now interested in example 4. Okay, see example 4 here. Okay, and this is for it is written if there is a wise problem, then you more focus on what is it written and how it's going on. Okay, so step 1 is write coefficients of this divided. Okay, so 1 negative 1, sorry 1 positive, and here okay, here one term is missing, that is x cube. So can I write 0x cube? So that's why after 1 there is 0, negative 10, negative 2, 4 means I have written here x power 4 plus 0 power x cube plus sorry, negative 10 x square and plus minus 2x, sorry, minus 2x plus 4. And if this term divider is equal to 0, then you will get x equal to minus 3. So that's why we are writing x negative 3. This is step 2. And then step 3 you will follow the pattern. Step 3 is very important. You will to write this one same as it. So what is 1 times negative 3? This is multiplication. As you know that 1 times multiply, so 1 multiply negative 3 equal to negative 3. So you will write here negative 3, and then you will to add these two terms. So 0 plus minus 3 will become negative 3, and then after that you will to repeat this pattern. Okay? Now multiply negative 3 with negative 3, so negative 3 multiply negative 3 will become positive 9, and while adding you will get here negative 1, y plus negative 10 plus 9 will become negative 1, and then you have to repeat, negative 1 times negative 3, so this will become positive 3, and minus 3, sorry, minus 2 plus 3 will become 1. And again, after repeating 1 times negative 3 will become negative 3, and after that you will get ये मैंने रिकॉर्ड पे रखा हुआ है, तो उसमें भी आप अच्छा रिकॉर्ड में सही होता है, आवाज आगे से आता है जिसका आपको पता आता है. पता नहीं क्यों मसला ये होना तो नहीं चाहिए, क्योंकि यहाँ पर तो सिग्नल मतलब आई भी बैठा हो तो कोई मसला नहीं है, और माइक भी ठीक है, लैपटॉप भी ठीक है. आप लोग के यहीं पर तो नहीं मसला नहीं आवाज का. इसमें दो चीजें आप लोगों ने ध्यान में रखनी है. टू थिंग्स दैट आर वेरी essential for you. One is the last term is always your remainder, and other thing, before this last term these numbers will be known as coefficients of your quotient. the degree of quotients will always become 1 lesser than your dividends. Degree will become n minus 1. So why? Because our dividend was n4. So the quotient will become half degree 3, 4 minus 1, 3. So this one is coefficient of x cube minus 3 is coefficient of x square, negative 1 is coefficient of x, and the last term will be constant. Clear?
सर 2 घंटे हो गए हैं, बस क्लास अब खत्म करें आप।
तो बताइए 3 घंटे सीआर ने बताया कि हमने बस किया हुआ है। हेलो तो 5 बजे हम क्लास खत्म करते हैं, ठीक है? डोंट वरी।
साईं आवाज नहीं आ रही सर, प्लीज सर इसको रोक देना सर, आगे नहीं पढ़ रहे हम
अभी
सर, अगली
बोलिए
क्लास में पढ़ लेंगे सर, अगली
मेरे
क्लास
पास
में पढ़ रहे हैं सर। अब सर आवाज बिल्कुल भी नहीं आ रही सर, पहले वाला जो टॉपिक था ना वो भी मेरा जो समझ में ही नहीं आ रहा था सर, आवाज आपकी बिल्कुल भी सही नहीं आ रही
मैंने तो आज शुरू में क्या लगाया।
सर। अभी भी आप बात कर रहे हैं ना, वो समझ में नहीं आ रहा कि आप क्या बोल रहे हैं सर,
हमने
वही
आपको
समझ में नहीं आ रहा।
व्हाट्सएप प्री कैलकुलस वाला जो ग्रुप है ना, उसमें आपको मैंने रिकॉर्डिंग करके भेजी, आप देखना आवाज एक
Okay, Agnes, please. For second class, Abdul Rauf, Abdul Sami, Abdul
Present, sir.
Sattar, Sami present, Abdul Sattar, Aisha, Amida, Amjad,
Present, sir.
Asadullah.
Yes, sir.
Agnes में तो आवाज सही आ रही है
सर आवाज से नहीं सर, हम अपना नाम बोल रहे हैं।
अमजद हो गया
नेम सुन के बस प्रेजेंट बोल दो ना।
Yes, sir. Present.
असदुल्लाह अवेश फयाज फयाज हुसैन भूमिका किशन
Yes, sir.
फराज
Yes,
अनिला
sir. Sir, मैं present हूँ.
फजलुल्लाह
Yes, sir.
हमजा इशरत अमरान करम किरण कोयल
Present, sir.
बदरलाल मानूर मोहम्मद हसन मोहम्मद अली मुसफ्फर
ठीक।
मुस्कान
मुस्कान भी प्रेजेंट लगा है, उसका नेट इशू आ रहा है.
किसका मुजम्मिल नजीउल्लाह फरीद रीना राधिका
Yes, sir. Yes, sir.
राजा फराज सलादीन
प्रेजेंट सर।
सवेरा सेजल
Yes, sir.
सिकंदर
Yes, sir. Yes, sir.
सुरेश उसामा सुरेश नहीं है उसामा भी नहीं है जीशान
Yes, sir.
अब्दुल रज़ाक अब्दुल सत्तार सेकंड अब्दुल सत्तार Adil. Amit.
Sir, Amit present.
Akhtar. Azala Salim. Hassan Ahmad. Kanchan.
Mama.
Anur. Moin Khan. Muskan.
प्रेजेंट सर। सर आपने मेरी प्रेजेंट नहीं लगाई आप कंचन।
Zamil Khan. Sanjay Kumar.
ओ ये टाइम नन्ना ॾाढो ॾुखियो
Shabir.
जी सर।
Shivani. Sonia.
आपी फरजाना भी मोकलिया भी बज रज़िया भी घणी
Saira. Razia भी मोकली. Sonia. Osama. Masroor.
Present, sir.
Gayur. मस्रूर कार्य में तो मेरा भी है।
सर मोहम्मद सचल की नेट का मसला है
सचल
वो डिस्कनेक्ट हो गया है
और सायरा
प्रेजेंट सर
और कोई
सर
जिसको
प्रेजेंट
मैंने एक्शन किया जो प्रेजेंट हो
हाँ
तो आप लोगों का ये होमवर्क है ठीक है नोट कर लें
सर होमवर्क क्या है बताएं तो।
आप लोगों ने क्वेश्चंस करने 2.3 के और आप लोगों ने देखा अगर उसके बाद कॉम्प्लेक्स शुरू हो जाती है ठीक है तो वो हम नहीं करेंगे और नेक्स्ट में हम चैप्टर 3 करेंगे ठीक है तो आप लोगों का चैप्टर 2 जो है वो है 2.1 2.2 and 2.3
2.1 2.2 2.3 question
beyond
from
next
2.3 next beyond
excluding okay सो होमवर्क ये है कि आप लोग जो रिमेनिंग टॉपिक्स हैं, ठीक है, अभी हमारा मंडे का क्लास था, तो इन एक्सरसाइज के लिए स्पेशल इक्विपमेंट थी। एक ही टॉपिक है, आई थिंक वेक्टर थ्योरम।
ಇಲ್ಲ ರುಖ ರುಖ ಚಾಮರದ ನಾನು ಹಲನಿ ನದ ಅಂದರ್
फिर आता हूँ तो कहीं सारा अकेला अकेला चावल रखा हूँ स्लाइड में। सियारे ने तो फाइनल में बहुत लग रहा हूँ।
सर आवाज कट जाए तो ता जो मतलब कुछ समझा चाहे तो मुझे नालो खयो ता लाए अॻियां छा चयो खबर न पई।
मां तो अकेला अकेला जेको चांवर खाए तो क्लास में सलाह बि नथो करे, उन ते फाइनल नालो
साईं जेको तव्हां जेको असाइनमेंट इहा जेका ॾियो पिया न होमवर्क इहो ग्रुप ते अगरि तव्हां शेयर कयो त जेको आहे न सही आहे। हिते सर क्वेश्चन सम्झ में ई नथो अचे तव्हां चवण छा था चयो असाइनमेंट जे अंदरि। सर
यस
सर जेको तव्हां हाणे चयो आहे न जेको होमवर्क इहो सर असांखे ग्रुप जेको आहे न प्री कैलकुलस वारे ते हुन ते सर शेयर करे छॾियो त पोइ सर सां ख़बर पइजे। हिते सर तव्हां हाले छा चयो ख़बर ई न पई।
ठीक है, मैंने जो बोला है वो यहाँ पर लिखा हुआ है, ठीक है।
ठीकु आहे साईं।